Okay, so here we're going to talk about the quotient rule. So remember, this is for taking the derivative of the quotient of two functions. So that's when we divide one function by the other function. So here we'll have the derivative of f of x over g of x. Right? And so the quotient rule is going to be a bit more complicated than the product rule, but trust me, it is nice to have because it can make things that would take a lot more work take significantly less work. And so I'll explain more about this later on when we learn the chain rule and show you why the quotient rule is just a combination of the product and the chain rule. But for now, you should just memorize it. And so the quotient rule is going to be, maybe I'll write it in this order. So we start with f prime of x times g of x minus the derivative, so g prime of x times f of x, and this is all over g of x squared. Okay. So this is the quotient rule. So what you see in the numerator, it looks really similar to the product rule. The difference is that there's a negative sign in the middle. And so that means that unlike the product rule, it does matter which order we write this in. We still have one derivative in each term, but it is important that we start with taking the derivative of f, which is the numerator. So we start with the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, and then this is over the denominator squared. Okay? So probably the biggest mistake that you could make is flip-flopping these and getting right, so just swapping those. So make sure you get those in the right order. Okay, so we're going to do several examples applying this. So here we have h prime of x, and that is going to be, so see, it's pretty easy to see what f and g should be in this case because it's just the numerator and the denominator of the function. So starting with f prime, that would be the derivative of this, which we can use the power rule on. So we would get 5, because the constant out front, times 2x. And then we multiply this is our derivative, by just the denominator. So 4x plus 3. And then, I'll clean this up a bit. And then we take the derivative of the denominator, which will just be 4, and we multiply that by the numerator. Okay. And then we have this over the denominator squared. Right? So we can simplify this a little bit. So we would get 10x times 4x plus 3 minus 20x squared and I usually prefer to not multiply out the denominator, so I will just actually leave this alone, and then we would get 40x squared minus 20x squared, so 20x squared plus 30x over the same denominator. Okay, so that is applying the quotient rule in that case. Okay. Here we have another quotient of two functions. So we are just going to start with taking the derivative of the numerator, right? So that's going to be, maybe for this example, I will write this out in pieces. So if you, so just to go through this example a little bit slower than the first one I did, this is going to be, so our numerator function is x squared plus 1. The denominator, which we'll call g, is x cubed minus 1. And then we can go ahead and take those derivatives now. That's 2x, and then g prime is 3x squared, right? And so y prime is going to be, maybe just for reference, I'll write down the formula for the quotient rule. So we start with f prime times g, then we get f times g prime over g of x squared, right? So we would get 2x times 3x squared minus, here we have f, which is x squared plus 1, times, the derivative of g, so 3x squared. Oh, wait, what happened here? Oh, sorry about that. I used the wrong thing in the first term. Okay. We have f prime times the regular function g. So this should have been x cubed minus 1. And then we have f, which is x squared plus 1 times g prime, 3x squared, over x cubed minus 1 squared. Okay. And I think I'm going to, okay, so we'll just do the simplification. So this will be 2x to the 4th minus 2x, and then if we distribute that 3x squared, we'll get 3x to the 4th plus 3x squared. So just so you know, if you're doing a problem and you're not sure whether to simplify or not, I will tell you specifically if you don't need to simplify the problem, or simplify your answer, that is. Right, so if I tell you, like, do not simplify your answer, then you don't need to worry about it, but otherwise, you can assume that you probably should simplify your answer. But again, no need to multiply out the denominator. Okay, so here we have a function that is the quotient of two functions, right? So actually this is one where we could compute the derivative without resorting to the quotient rule. So how we would do that is by simplifying, so splitting this into two fractions. We get t over t squared minus root t over t squared, right? And so this would, one of these t's would cancel in the first term, so you get 1 over t. And then in the second term, I can rewrite this as t to the 1/2 over t squared. And then if we remember our exponent rules, we would just take 1/2 minus 2. The first term, this is t to the minus 1. And then we would get t to the 1/2 minus 2 will give you negative 3/2. Okay, so then it's in the form where we can just apply the power rule. Now, what I'm going to do is go ahead and use the quotient rule on this, just to show you that it's not always the best idea to use the quotient rule, because it can be a lot more work. See that it only took us 3 steps to get it in a form where we could use the power rule. Whereas, I don't know, you can always, you can use the quotient rule, so it's really up to you. But personally, I would go this route. Okay, so we have the derivative of the numerator. That's the first thing. So we get 1 minus the derivative of square root of t. Maybe I'll write this down here so that we don't have to do this in our heads. Right, so this is the derivative of t minus t to the 1/2. Notice when I say the derivative, this t matches the variable that I'm using in this expression. So we get 1 minus 1/2 t to the minus 1/2. And so that's what we're going to put up here. 1/2 t to the minus 1/2. And then so then we multiply by the denominator, t squared, minus the derivative of the denominator is 2t, and then we have the numerator, t minus square root t. And then don't forget that this whole thing is over t squared squared, right? So this is a case where it's probably nice to simplify the denominator, right? So I think I'm going to leave the simplification up to you. You should try it if you need practice with these things. But this would be root t over t to the 4th. Okay. Right. So let me just, this went up there. Okay, and then we have one more example here where you can do this basically in the same way that I did it in the first case, or you could use the quotient rule. And again, okay, so we'll see what it looks like when we try to use the quotient rule here. So what I'm going to do is compute the derivative of the numerator off to the side. And remember that we would want these in the form x to some power so that we can use the power rule. So I'm going to do that right now. This would be 2x plus 1/2 x to the minus 1/2 minus 1/3 x to the minus 2/3. So that's the derivative of the numerator. We can go ahead and use that in our formula. The derivative of the denominator is just 1, right? Because the denominator is just x. So I won't write that part out. G prime would give you, let's see, 2x plus 1/2 x to the minus 1/2 minus 1/3 x to the minus 2/3 times just x, the denominator, minus 1 times the numerator, so x squared plus root x minus the cube root x. And then over x squared. Okay, so that is what you get from the quotient rule. Now I want to compare this to, compare to how it would work if you were to first simplify this by splitting it into 3 different fractions. So we get x squared over x plus root x over x plus the cube root of x over x, right? And then we would get x plus 1 over root x. Just double check that you agree with that. And then here we would have 1 over the cube root of x squared. Now I didn't write out all of the steps here, so you could rewrite these using exponents and then use your exponent laws. I sort of skipped some steps there. But let's see. So we rewrite these so that we can use the power rule on them. So this would be, it would look like this. And then g prime is equal to 1 minus 1/2 x to the minus, so 1/2 minus 1 would give us 3/2 minus 2/3, that came down, and then x to the 2/3 minus 1, negative 5/3. Okay, now compare this answer, which is already simplified, to this answer, which is a big ol' mess, right? So if you had to, say, set this equal to 0 and try to solve it, it would be a nightmare. It's a lot easier to set this equal to 0 and try to solve it, right? So that's the reason why you want to almost use the quotient rule as a last resort. I did say it does simplify some calculations, but you shouldn't use it if you don't need to, right? So just keep that in mind. Notice that the thing that was common between these last two examples was that we could split these into fractions and simplify so that we just got powers of t or powers of x. And so that is something to look for. If you had this flipped, if you had x over x squared plus root x plus the cube root of x, it would not work because of the rules that we have for fractions. We can't split this into separate fractions, and in that case you do have to use the quotient rule. Okay, so don't forget to do the comprehension check question.